All right, in this next unit, we are going to learn about the development of the periodic table and something called the periodic law, where the elements, when they are arranged properly, that they tend to have similar chemical and physical mainly chemical properties in the same vertical columns. To do this first activity, here's a copy of the packet that is online, which you're going to need to have access to. So on your iPad, you can find that. But on page 2, you are going to be given cards. Each one of these rectangles is an element that has a set of chemical properties given to you. Melting point, its boiling point. O in oxides is how many oxygens it bonds with. So for example, in this middle one right here, it says 0.5. What that means is when this element bonds with oxygen, forming an oxide compound, it does so in a ratio of 1 of it to 0.5 oxygen. Now that physically can't happen. You can't have a half of an oxygen atom. So what we have to do is we have to double both those numbers. We have to keep the same ratio. But instead of being 1 to a half, it becomes 2 to 1. So this element would bond 2 of it for every 1 oxygen. So that's what these numbers mean here, is what ratio is it? 1 to a half. This element right below it here has got dashes in it, which means it doesn't react with oxygen. So it would not form a chemical compound with it, okay? And then we get some like down here that might have like 3 here. So for every one of that element, it bonds with 3 oxygens. So it'd be X, whatever it is, and 3 oxygens. Now you're going to cut these cards out, and to do this activity, your job is to develop the periodic table from them. Now, to begin this activity, I need you to read the textbook pages, and I've supplied those on Canvas. Right below the copy of the packet, there is about 8 pages of textbook pages that I've supplied to you. Read the first 3 pages, 151 and 154, and after you read them, fill out these questions, which is going to go into introducing this development of the periodic table. What was going on in the late 1700s, early 1800s that started this development before the periodic table was made. Once you got those questions answered, you'll then read these directions, which is pretty much what the video is doing now for you, to go ahead and complete the activity. You'll need to print off the cards and then cut them apart. If you don't have access to a printer, just go ahead and create 20 little pieces of paper and number them, okay, with their masses. So 1, 19, 36. Okay, you don't have to write down all the information because the other cards are already given to you. But at least have the masses of the elements. And then you'll need to have the pictures of all the data to do the final activity, okay? Once you've got the cards printed off, what you are then going to do is arrange them, and what I would do is I would put them in order of increasing atomic mass. 1, 4, 7, 9, 10, so on and so forth. The heaviest element has got a mass of 40. So once you have them in this long chain, what you then need to do is to arrange the cards. These element cards represent hydrogen through calcium. Yes, hydrogen through calcium, the first 20 elements. But I haven't told you what they are. You can use mass to start arranging the periodic table. However, later it's found out that mass is not the true final say into how the periodic table is arranged. When you are done, you should have a periodic table. Now, if you think about a periodic table, you have access to one already. But if you were to look at the first 20 elements, stopping with calcium, you'll notice that there are no elements after calcium. With that, your periodic table that you're going to make is going to contain, okay, 2 rows with a little bit of a gap, and then 13 to 18. You should end up having 8 total rows, vertical columns, I should say, 8 vertical columns, in which the first vertical column will have 4 cards in it. The next one will have 3. The next one will have 2, 2, and then the very last column will have 3. So when you're done, that is what your card arrangement should look like. Okay? Here's an example of one that I've done for you. This is what your card should look like, but this is not the correct order. I've just randomly thrown the cards in there to give you the basic shape. But when you are done, when you look at a column, you should notice that their properties are of a similar nature. You'll notice here, and I specifically usually use the oxides and chlorides. They're the best in figuring out that value. This element card is 1 to 2, 0.5 to 1, 0.5 to 1, 1.5 to 3. that right away tells you that these cards aren't in perfect order because they should have very similar properties. And therefore, you should have the same bonding arrangement to oxygen and chlorine when they form chemical compounds. So, first use mass to organize the cards in the order that we've done, going from the lightest element to all the way to the heaviest element. And then look at the properties given and see if they match. If they don't, you might have to make maybe small little arrangement changes so that the properties of all the elements in that family have similar chemical properties. And this is what Mendeleev found. This is how they began organizing the table. They only put cards of similar nature, similar properties in the same vertical family. And once the vertical family was created, they then arranged them, and that was the start of the periodic table, which is what this activity is having you do. Once you have got the cards aligned, you think you got it right, take a picture of this, and then this is what you will submit. The picture of this will be submitted into Canvas for completing this activity, for those of you that are virtual. If you're going to show up to class, either the last week of October or the first week of November, we're going to be doing this activity in class already. So you don't have to do this if you're coming to school. Now, if you're at home or you're absent or you're a virtual student, these two activities we're going to start off the unit you'll have to do, and you'll have to just make sure to upload the pictures when you're finished with them. If you have any questions, ask me. Once the activity is done, then you need to go to page 3 and answer the remainder of the questions. And again, the answers to these should be found in pages 151 to 154. So the first 4 pages you'll need to read, and from that information, complete those questions and submit the picture of the periodic table. And that's all I need. I just need the picture of the cards, and then I'll look at those numbers, make sure it's visible for me, that I can then tell you if you got them right or wrong. Okay, so that's the first activity. You're going to be acting as Mendeleev and seeing how the initial periodic table was first developed.